Okay, hello everyone. Good afternoon, all of you. So we start with a quote of the great lady Oprah Winfrey. Don't worry about being successful, but work toward being significant, and success will naturally follow. So don't focus on success. Automatically, the focus will come. The success will come to you. Only thing is work toward being significant. And today is the birthday of Thomas Blanchard. He is an American inventor who made major contributions to the development of machine tools. So as a mechanical engineer, he's uh, very famous for me. And he invented a number of machines before he created the famous lathe that bears his name. Okay, Blanchard lathe is very famous. And at the age 13, he developing an apple paring machine developed. Okay. Blanchard came up with a machine for mass producing the tacks. He went into the armory business, for which he developed a specialized lathe which could turn irregularly shaped parts such as gun stocks. Blanchard profile lathe also revolutionized other industries that manufactured. Okay, it's not saying here. Okay, today actually we are going to discuss isometric projections with AutoCAD. Okay, before that, I think some people
So we
have.
have doubts
Yeah,
in
yeah,
the
sure, we will
planes.
discuss. Okay, tell, that is
So so circles
AutoCAD
and
with.
arcs. So can we do two questions based on that?
Okay, circles and arcs actually, the cycle anyhow you can draw straight away.
No, sir. Circle also is a problem. So please, can you do circle
Okay,
also?
okay, we will do it.
So something like how protector functions in AutoCAD. That's more of a problem to me.
Which functions?
Like, are there any protractor functions in AutoCAD?
Arcs are
Arc,
there,
yeah,
na?
arcs
Yeah,
are there,
arcs.
but I wasn't able to do them properly in.
Anyhow, for planes, I think you need circles and ellipse, right? Those things we need. That we will
Yes,
see
sir.
how to do about it. Or even arcs also, we have what is called as spline. Actually, it's already 13 people have submitted. Okay, they have submitted it well. Just I will show you the uh, solutions that they have given, and we will discuss them also. Okay, I think Divyamsh, number two, he has done this. Divyamsh Dubey, he has done it well, right? So this is the first problem of hexagon, and this is the second problem of pentagon, and this is the third problem of rhombus. And okay, here he has done this circle, ellipse, and all. Okay, I think this problem only you find it difficult.
Yes, sir. This is the one, sir.
Okay,
And
and
then this one also, sir.
this one also, yeah. Okay, this is thing. These are the three problems I think you have got, and this is also. Okay, these are the things he has done. Okay, I'm not also actually good expert in AutoCAD. I am good at conventional drawing, but because we have to introduce AutoCAD, we have done this. Okay, anyhow, we'll see what can be done. Because you people are good at using computers and packages and all, you can learn it faster than our generation. Okay. Anyhow, so for circle, you can go to this and you have center and
So
radius.
how do you divide the circle into 12 parts, sir?
Okay, that you can do one thing. Okay, okay. First, I will let me draw the circle. Okay, so this we have done this, and you can draw lines. Actually, here if you take in the snaps, you can choose center. Okay, so the advantage of that I will tell. And if I put suppose line, and if I take this onto the circle, you will get the center automatically here like this. And I can draw this first line, and that is if you choose it. in the object snap, if you
पूरा ले
choose
लो,
center,
कुछ बचा तो है नहीं।
ये दे दो।
मतलब पनीर तो कुछ बचा ही नहीं, सिर्फ वही बचा पालक वाला। क्यों मैं नहीं खाऊं? तुम्हें चाहिए?
नहीं खाओ।
somebody is talking there. Okay, and so if you choose the line, and if you bring onto the circle, okay, anyhow, now we can get the center. So this center I can get, and I can get the vertical line and horizontal lines right away. And I can rotate these by 30 degrees, like the 60 degrees like that. So if I take rotate option, choose this line, enter, and select the base point. You can select the base point here and give 30 degrees. And copy, you take copy, and then you give 30 degrees. Otherwise, that line itself will be rotated. Okay, this is the way we can get it. Again, you can rotate this, select the object, enter, and select the base point, and copy, and 60. In that way, I can get all the points. Is this okay? Dividing this?
Okay, sir.
Yeah. And okay, drawing ellipse. Suppose I have got the major axis. Okay, I will take ellipse command. Okay, so in ellipse command, it is asking axis and points. So I can choose this point and this point, suppose. Now, if you just take it like this, I will get different ellipses. And if I click anywhere here, that decides the minor axis. Okay, so because I will be knowing another point on the minor axis, I can just click like that. In that way, I will get the ellipse. And I will get spline somewhere. Polyline.
So the draw option below. Draw option.
Arcs, huh?
Draw, sir, draw.
Which one?
So the draw. Below line and
Yeah,
polyline.
in the draw. Okay, here. Yeah. Here. This is the helix. I think these are splines. Yeah. This is spline. So spline fit we can take if you want some odd curve or something going through some points, and suppose something like that. If you have, I want to make some curve going through some points. So and this is best fit, and this is going through all the points. Okay, if I take this, and if I take this point, see, it comes like this. If I take another point like this, so like that, if I want to have a curve going through some points, I can choose those points, and you will get a smooth curve. It is called a spline curve. And usually why this spline came is, there is what is used to be draftsman's spline. So they will have a small plastic rod like thing, which can be bent in any way you want. So if I want a smooth curve going through some points, it is very difficult to draw a freehand curve. That's why if you take this draftsman's spline and bend it in such a way that it goes through the required points, then you can just join them like that. It is like a French curve. But French curve, there are only some standard shapes are there. But this flexible scale-like thing, if you take, you can get a curve through any number of points in any shape like that. So that is the way you can draw the curves. Anything else?
Sir.
Yes.
So in few problems, like we have to find the apparent angle from the true angle, right?
Yeah. You do like that. You draw actual line with the required length, and through that locus line, horizontal line you can draw, and you can take this length and you can cut it there. So how to cut it?
How do we do
Suppose if I want this length, okay. So take this circle and take this as the radius, and draw the circle, move that circle there, and wherever that circle cuts the locus line, that point you have to take.
So and rest of the unnecessary part can be trimmed, right?
Yes.
Could you repeat, sir?
Okay. Suppose here. Okay, this is the locus line I have, and here, okay, another point. Okay, something like this I have got, and I got this locus line, right? So this is XY line, the top line, and this true length line, something I have drawn, and so I can take this length, the true length, whatever is there on this, and then I can draw another horizontal line or parallel line to this, and so I will get the locus line. So here, if I take the circle, okay. Okay, if I have some true length here, that is apparent length, and suppose if I take a circle, and okay, otherwise, okay, suppose this is the circle. So what I do is I move the circle, and take this as the base point, and fix here like this. So that so I will get this apparent line here like this angle. So through this point to this point. So that will be the apparent length, and so this will become apparent angle. So like that I can do it. Is it clear what I'm telling?
So and how do we reproduce the second position from the apparent angle, new apparent angle?
That is this one.
Yes, sir. Yeah.
And that's what I'm telling. You know the apparent length here. You draw a circle there, you move that circle here, so that I can find out wherever this circle cuts this. So that is the point.
So from there, so like rest of the diagram we need to complete, right?
Yeah, rest of the diagram you have to. So again,
How do we do
you,
it?
yeah. Suppose okay. Suppose a hexagon or pentagon is there, and suppose this is the diagonal. So whichever one you, because one of the base point you can fix here, or if diagonal has to match. Okay, how can I say that? So you have to take the point on. Okay. Okay, something like this, suppose I have. So this is the apparent angle will be this. Okay, 90 degrees. And I have to match this point to this point. I think one other person, whoever has answered, can respond to this. Okay, Divyansh, I think you are there, Divyansh Dubey.
Yes,
So
sir.
do you remember how you have done that?
Yes, sir. I have done it and then remove the unwanted part, sir.
Okay, he is asking, okay, this is to be taken here to the
Yes, sir.
required position. And what is the way to be done?
Just copy the whole figure
Yeah,
with
okay.
along with the projection lines, because if we remove the projection lines here, then it is difficult
Yeah,
to
I
draw.
remove the projection line. Only this ellipse only I want, right?
Yes,
Only
sir.
this ellipse-like thing I have to select. I
Yes, sir.
have to see that this A matches here.
Then, sir, take it and copy it and then rotate it.
Here it is 90 degrees, it's no problem actually. We know
Yes.
what is the angle to be rotated. But if it is some arbitrary angle, because auxiliary plane there only comes, nobody, no, nothing else. Okay, anyhow, in this particular problem, you rotate this by 90 degrees and take this as the base point and move that base point here. So that is the straight away thing.
Yes, sir.
Is it clear? Who is asking?
So me, Nitish.
Is it clear what I am telling?
Yes, sir.
Because it is only 90 degrees, clearly it is to be rotated. Here it should not be a problem, right? So you have to take this as the base point and you can match it here and you can rotate it by 90 degrees. That's okay there. Okay, some more things I wanted to tell. Any other doubts? I want to tell how to use auxiliary plane method. Okay, just suppose if I take the previous class problem, X7. Okay, here we have done like this, but instead of this, if I want to do it like auxiliary plane method, suppose A, copy, I will take to another sheet. So, so like this, if I have, instead of rotating this here, I want to use the auxiliary plane method. So what I do is I remove these things. Okay, if I want to do auxiliary plane method, maybe I think 60 degrees or 45 degrees, what is it? To rotate 60 degrees. Okay. So I want to draw a 60 degrees line here and I have to project this and take these distances and transfer there. Okay, so auxiliary plane method, I think all people remember. Okay, the concept of auxiliary plane method, just I will just repeat so that for the exam there will not be any difficulty. Okay, I am just repeating the auxiliary plane method concept. So what we have done is, we have taken the X7 We have taken this and we have turned this by 45 degrees. And okay, something like this we got. And now I have rotated this. Instead of rotating this, if I draw an auxiliary line, so making, I think diagonal has to make 60 degrees. So with this diagonal, if I draw a line, XY line, making 60 degrees. So then so we have to draw like this. And so what the actual thing what we are doing is, we are drawing the lotus lines here. Okay, so here I am rotating this and I am producing the projectors and transferring these front view distances from this XY line. Okay, so the same concept what we do is, instead of rotating the object, I am rotating the XY line like this, and I am drawing the projectors. And after drawing the projectors, because I know the distances from the XY line, those distances I have to transfer there. Okay, so these distances, suppose if it is A, B, C, D, E, F, A dash, F dash, B dash, E dash, C dash, D dash. So here also A dash, F dash, C dash, D dash, E dash, C dash, dash. So A will be here itself, and B and F I have to transfer this distance. So on the B I take some distance here, on the F same distance I will get. And the C and E I have to transfer this distance. So on C I will get some distance here, on E also same distance I will get. And on D I have to get this maximum distance, and so I will get somewhere here. So this is A dash, B dash, C dash, D dash, E dash, F dash, like this I will get. Okay, something I will get like that. I have to get those points in that way. So what is happening is, so I am going to get the front view and top view in this way with the XY line here. The whole front view and top view are rotated by 60 degrees. So this figure, which I got this way, I am going to get in this particular direction. Okay, so we will see how it can be done. So here I have to get an XY line 60 degrees. Okay, so what I will do is first I will draw one straight line, and that I will rotate by 60 degrees. Okay, rotate, you take this and choose this line and choose this as center, and 60 degrees I rotate that. And okay, now I can draw these projectors. Okay, now to draw the projectors, I have to draw perpendicular lines to this XY line. And how to do that? Okay, there is one command called as UCS, User Coordinate System. I can rotate my coordinate system to any direction I want. So here there is a command called UCS, User Coordinate System. Okay, enter. And it is asking specify origin. Okay, so I choose this and give and another point on the x-axis. So this I will put. Okay, just like that. Enter. So your XY coordinate system has changed to this particular direction. Now, if I want to draw perpendicular lines to this, just you choose the ortho. Okay, so all horizontal lines and vertical lines to this XY line I will get. So what I do is now choose I think I have. Yes, ma'am. I don't know whether I have clicked the isometric now. Okay, I think this is it. Fine. So click like this, and it should be perpendicular ortho. So like this I will get. So click it, enter, enter, click, enter. Fine. Sometimes that snap it takes some other time. So like that I have to draw the projectors. Now I have to transfer the distances. Okay, so this is A anyhow 0 distance. For B and F, I have to transfer this distance. Okay, so for this distance, what I have to take is this one. This is offset. Okay, so click on the offset, and it is asking offset distance. Okay, so you give the two ends of this smart line. Okay, this is the line distance I have taken, and which is to be offset. This XY line I choose, and I will get a parallel line either that side or this side. Okay, I want this side. I click on that side, so you will get a line. Enter. And similarly, you want another distance for C and E. Okay, so again you take the offset, take this particular distance, and again click on this side. Okay, again offset, and take the distance of D point, and click on this again. Yeah, I think all the 3 lines I got. Okay, so now I have to join the hexagon. So you can take maybe polyline if I take, and so this is the first point A, and you will get to B here, and C here, and there, and maybe A here. B here, B here, B here, B here. Okay, like this I will get. So if you see the shape of the previous one, this is also you will get the same thing. Only thing is you will get in this way, front view and top view. Here you are going to get at a different angle like this. Okay, this is the way we have to use 2 commands. One is user coordinate system, how to change it. So once you change it, using also I can draw the projectors. Then to transfer the distances, I have to take the offset command. So for the offset, you have to give how much is to be offset. So you have to give the two ends of the distance of the line by which I have to offset this. So which line is to be offset? This XY line is to be offset on the upper side. So you just click there, you will get a parallel line. Like that, you will get the line. So wherever these intersect, you will have to get like that. Any doubt about this? Okay. So today, so once you understand, okay, only these comments are sufficient to draw either projections of solids or sections of solids, anything, because only these concepts are sufficient. If you know how to draw conventional one, you can be able to draw this on the AutoCAD. Okay. So actually today I want to do the isometric projection. Okay, there are some standard things. First, even for the regular one also, always better put limits, LIMITS. At the beginning of the drawing itself, you can limit your dimensions of the sheet so that you will not get the coordinates as 1500, 2600 like that. Okay, so limits and lower left corner 00 only. And upper right corner, usually the better thing is 120 by 90, okay, like that. So that if I take the coordinates anywhere, suppose if I take this, the dynamic coordinate system. Okay. Okay, that is the way it is better. And okay, if you want to draw the isometric things, so you have to give snap command. Snap, enter. And here what is called as style is there. You take style. In the style, you have standard and isometric. So whatever we are doing is standard. Now choose isometric. Okay. And okay, vertical spacing 0.5, that is okay. And again, you better snap off. Okay, snap, enter, you take off. Okay, now you can see that the cursor is like this. Why I have given snap off is, if you give snap 1 or snap 0.5 or something like that, the cursor jumps by that distance. Okay, if snap is 10, it jumps by 10 units. If it is 5, jumps by 5 units. If I snap off, it will move smoothly wherever on the screen. Okay, and it is changed, the cursor shape is changed. And there is a F5 key. If I click, you can see that the cursor is changing. So this is, suppose if you see the cursor, it is top surface. And this is left surface. This is the right surface. Like that, I can do any sides of the isometric projection. Okay, this is the way I can do this. This is one of the things you have to remember. Okay, in snap, style, isometric. Okay, so you will get this particular one. And so here to change this, F5. Okay, F5, if you are go on typing, it changes the cursor like that. Okay, you can see this is isoplane left, this is isoplane top, this is isoplane right. Here it is coming like this. Okay, so that is the way I can change it. So once I know what is the shape, so suppose I take some problem, and okay, so just a cube I will draw. I will take here, and I take ortho. Okay, like this, I take 5. Okay, 5 I am taking the length, And this either I can draw this way or this way. Okay, so I am taking this way. Again 5 length, enter, and up 5 length, enter, and this side you bring it and you close it. Okay, so this surface came. I want the top surface, suppose, and F5 I type, again F5, and the line command. So you take here. So this is 5 this side, and this side 5, and again come back. Sorry, not this side. Line like this, 5 this side, and 5. Okay, and I want this square. These are rhombus, whatever it is. So I have to change the cursor again like this, and the line you take this way, 5, enter, and I have to join here. Okay, so I can draw like this. And another thing I want to say is how to draw these ellipse-like things here. Okay, so how to do that is,
Sir, how are you changing the cursor?
cursor F5. Okay, just F5 you try. See, it is continuously changing. I am typing F5 like that. It goes isoplane right, left, and top. So here you can see the command isoplane left, right, and top. Is it okay? And here also it is there. You can see here isoplane left, right, and top. So using this also you can change. But the quick access key is F5. Is it okay? You can
Yes,
see
sir.
the cursor is changing. Okay, like that. And so, okay, line I draw and remove the ortho. Just I draw the diagonals. So I want to draw the ellipse here. Okay. So for that, what I do is I take ellipse command, ELL, ellipse, and it is asking, you take isocircle here. In the circle, I have ellipse and the isocircle is there. You choose isocircle. Then it is asking center of the isocircle. Okay, you click here. And if I do like this, I am getting ellipse. But it is getting in another plane. And the type F5, just it is changing into another plane. Again, now it is coming into top plane. Now I can change the size and click on this point, midpoint of the line. Just click there, it will settle like that. So another I want, suppose, again I type ellipse. Okay, I choose the command ellipse, and isocircle, I click it, and again asking center, I take this center. Now it is coming in this way, but again I want to change the plane. So F5 if I type, it is coming like that. So where should I click? I have to click on one point on this, that is that center point of that one. So I can click there. In the same way, one more ellipse, isocircle, and click here. And again, I have to change the plane, F5. Okay, this is the plane I got. Okay, so sometimes you need half circle or quarter circle like that. What I have to do is I can remove the unwanted parts. So go to trim, PR, enter. What is taking something else? The PR. So now this cross mark is coming wherever I take. So I can suppose only this quarter I want. So I can remove this. I can remove this if I want. I can remove this if I want. I can have a semicircle, right? And if I want quarter circle here, I can remove this part, this part, this part. Individual parts I can remove like that. And here, suppose I want this larger arc, I can remove this. So like this I can do. I am undoing that. So whichever part I don't want, I can just trim. Okay, so any part I can remove. Okay, like this. And this is a larger arc, right? So similarly, I can retain shorter arc. Whichever one I want, I can do that. Could you understand that? So first you have to draw the whole ellipse, and whichever part is not required, that can be removed. Okay, and one more thing what I have to show is the dimensioning. Okay, so that is important. So suppose I want to dimension this. What I have to do is, you have to go for aligned dimension, aligned, not linear, aligned. Okay, so taking aligned, I have to click here. Suppose click here, I am getting like this. But nothing is seen. The dimension size and R are not good. So I have to go for the annotation, and you have to modify it. Manage dimension styles, modify, and maybe I can take 2. Okay, okay, close. It is becoming too large. Point 5 or something. Or point 0.4 I'm taking. Yeah, I think this is okay, 0.4. And I have to remove the decimals. Okay, annotation, standard, manage dimension style, modify. And in the primary units, I have to remove the decimals, take 0. And the arrows also, symbols and arrows, same size I have to keep, 0.4. Okay. Yes. Okay, I got nicely. And so here, but this is the way I have to, this is not the way, because these horizontal lines are not isometric lines. Am I right? So what should I do? I have to get these lines in this direction. And so I have to change the direction. So first I will put all the 3 sides. Okay, again, aligned. Okay, this side I put. And it is getting like this. And again, aligned. Okay, this side and this side I'm taking. It's getting this side. But okay, this is not the way I want. Okay, one more also I will put. Okay, this not necessary. This is redundant, but I am just keeping like that. Okay, now I have to change the directions of the dimensions. So there is what is called as dimension edit. Okay, DIMED. Okay, DIM means here you will get DIM edit. I have to take that, and here in this oblique is there. So I have to take oblique, and then I have to change whatever dimension I want to change, select the object. So I am changing this, taking this. I selected it, enter. And then I have to give at what angle I have to change it. So this extension line angle I have to give. What is the extension line angle should be?
30 degrees.
30 degrees. So I give 30 and enter. Automatically it changes. Okay, suppose I want to change, and if you want to change to 30 degrees some 3-4 dimensions, all dimensions you can select whichever is to be converted to 30 degrees. All of them at the same time you can change it, because select objects when it is asked. So you have to select all the objects which are to be rotated by 30 degrees. Okay, suppose I take for these two. Okay, DIMED. And oblique, and I have to choose the objects, and you can see that this is to be given. What is the angle of the extension line here? what should be the angle of the extension line? It should be vertical, right? Because this is between these two lines, okay? Between these two lines means extension line should be in the same direction. Okay, so 90 degrees. And if you see this, for this also, the extension line should be 90 degrees. So both of these should be turned to 90 degrees. So I have to select this and also select this and put 90, enter. Okay. Again, it is asking select objects. Okay, enter. And oblique angle 90, enter. See, it changed like that. And suppose if this is there, and for this, the extension line should be in this direction. So again, if I give DIMED, enter, and this is to be oblique, and select the object, enter. And what is the angle I have to give for this? Okay, this angle I want. Angle of this line is with the positive x direction. What is the angle of this line?
150.
150, yeah. So 150, enter. It will come like this. So these are the three angles normally I want. Either you turn to 30 degrees or 90 degrees or 150 degrees. Because all extension lines are ISO lines will be in those directions. Okay, that is the way I can change the directions of the dimensions. Is that clear?
Yes, sir.
Okay. I will do some simple problem. If I take exercise 20, if people are having that book, you can just look into it. Exercise 20. That's a steps problem is there, right? Staircase like thing. That problem I will do is figure 20.34. 20.34. Okay, suppose if I take that particular problem. Okay, I will remove this. So this problem, suppose if I do, I take line. Okay, first I will do the left side plane. Okay, suppose because this is in that cursor. So if I take this side the length is, and I will take ortho. Okay, the length is 72. 72. Enter. Okay. Over. Okay, it is gone somewhere. Just I will put enter. What will happen? Escape. Escape. Line. I'm taking 72 this side. Okay, I will zoom in. I'll Z, enter, extends, enter. Z, zoom, enter. Zoom, extends. Okay. So I can get this line like this. Okay, I don't want that XY there. UCS icon I can remove actually. UCS icon off. Okay, I can remove that. And okay, so then line. After this, the height is 48. I will type 48. And this length, what is it? 24. 24, enter. and down 16, enter, and this side 24, enter, and down 16, enter, and again this side 24, enter, and down. Okay. So this side I have done it, and the top side if I want to draw, just again F5 I type, so top surface is coming. So I will go to XY line, so click on this, and the length is 104, 104, enter, and this side it is 72, 72, enter, and this side is 24, enter, and it goes this way, 48, and this joins here like that. And now I draw in the other plane, F5 I type, and line, we choose this, and it comes down by 48, enter, and I can join here, and so these lines I can draw. And what is this length of this line? I think 104 minus 24, 80, 80, and up by 80, and it has to go to horizontally. So F5 I type this way, 24, and you can, okay, I can go up by 16, and again 24, and go up by 16. And these lines I have to get, so F5, change it, line, enter, then, and I have to get this vertical line, so again change F5, okay, and one more line I think here. Okay, this is the way I have to draw, and then you have to show all the dimensions in the way it is given in the book.
So which one dimension should we show, sir? I've had this doubt for a bit.
So whatever dimensions are given here in the problem, you have to show them. Okay, suppose, okay, align dimensioning, align. Okay, so this is there. This is one. Enter. Okay, like that we have to do wherever you want, and then first I have to change the text size in the annotation. Dimension size, modify, next. 0.4 didn't work here, so because they are big, I can put 3. I think this is okay, or I can take 4, I think. I'll take 4. And primary units 0, okay. And arrows 4. Okay, like this I can do. Now I can change the oblique dimensions and all. So suppose this is to be given 30 degrees, and these two should be given 30 degrees, and these two should be given 90 degrees, and these two should be given 150 degrees. We take DIMED, oblique, and select objects. So this and this, okay. Enter to select two objects, and oblique angle 30. So like that I can do. Suppose these two, DIMED, oblique, this and this, enter, and make it 90, like this. And these are to be given 150 degrees. And again you go to DIMED, oblique, select this, select this, 150. So like this we can do. Okay, so whatever dimensions that are given in the book, you have to show them. Is that okay?
Yes, sir.
Sir,
Yes.
sir, dimension should be outside the figure.
Because it is given in the book, whatever way it is given in the book, just you show them like that. Because
Okay, sir.
sometimes it is not possible, and sometimes it is preferred inside. Okay, for the clarity. So whatever way it is given in the book, you do it like that. You just reproduce. You need not imagine, think, or anything. So
Okay, sir.
this is the one. Okay, actually you will have two more assignments, and one assignment I will give you with 5 problems in solids and 5 problems in sections. And for this AutoCAD with isometric, somebody is talking, please just audio off. And so with AutoCAD, isometric with AutoCAD, so that will be 10 problems. So these 2 assignments you have to submit, which completes the number of assignments.
So, sir, now this isometric 10 problems assignment, and then after that you will give sections of solids also?
No. Solids 5 and sections 5. Those 2 together, only 1 assignment.
That's next
And
class, sir.
isometric 1 assignment. Only 2 assignments you have to do. Is it clear?
Yes, sir.
Okay, that way you complete the assignments. Okay, and the next thing is you are going to have the final exam on 5th July, Monday.
Sir, July 8th is the last working day, sir.
Yeah. Okay. You want after that? I thought you will be free from easy and you can study for the other exams.
Sir, 5 July is okay.
Right? Or 5 or what is the Thursday, 6, 7, 8? I think 8 also we can do. Monday or 8th, 5th or 8th.
So 5 is fine.
5 is fine, right? So you'll be free from this. But only thing is you have to submit the assignments by that time. Okay? And you will have 6 problems. 2 from straight lines, 1 from planes, 1 from solids, 1 from sections, 1 from isometric. 6 problems will be there. Already you have done the minor with 4 problems. Okay, now sections and isometric will be added. Totally 6 problems will be there. And the total time, 2.5 hours plus 20 minutes, 2 hours, 50 minutes. Okay, that is the way the thing will be. Any doubts?
On paper.
Yeah, same way, mid-exam, whatever way you have done, you will do in the final exam also. No AutoCAD for final exam.
Okay, sir.
Only these 3 assignments you have to submit for the AutoCAD. Any other doubts?
No, sir.
Okay, so I will be there. You can contact me anytime and you can mail me. And the next class also we will meet. If there is any doubt session will be there in the next class. Okay, today is Thursday, right? So next Monday will be the doubts class. And okay, one more thing. Okay, I am just as my duty, I am doing it. But actually, the way people are, I don't know whether the things are clear or not. Because solids now recently I have corrected and I have sent to you also. And okay, sometimes people have not submitted, they are so careless. So remove them. And then the remaining people also, there are some basic things. I don't know whether they are careless or they are not known. And I don't know because they have submitted, at least some interest is there. But it is so careless. And you, some of the people don't know how to draw regular pentagon and hexagon. That is very, very sad. Yeah, at least by seeing the figure, you should be able to understand it is hexagon or pentagon or anything, regular or not. Okay, one thing you tell me, regular pentagon, what is the meaning of that? A regular polygon means all sides must be equal, but is it sufficient?
Angle between adjacent sides should be equal.
All the angles also included angles must be same. Okay, that you must understand. Okay, some people suppose they do the hexagon like this. Okay, the pentagon. Okay, this is pentagon only, but here it is very small angle. Here large angle. It's not a regular pentagon. And I told you how to draw it also, right? So I don't know why people are not doing properly. And even the square, when it is drawn like this, it should be square only. It cannot be like diamond-like thing. Okay. It should be all sides must be equal, and also all angles must be 90 degrees. But for rhombus, it will not be 90 degrees. That is another thing. And one more thing, when suppose I have a triangle like this, and this is to be rotated in such a way that it is lying on its generator or on a slant edge like that. Okay, when you rotate it, it's so much easy actually. If this line is to be lying on that, first you take that line. And only this point is to be obtained. You know that length, this length, and also this length, you can just cut it and you will get it like this. And when you draw this, okay, so because this center line, this is perpendicular, this must be perpendicular. Okay, for many people it is not like that. Actually, they are doing something like this, and it is coming completely angle. It's not at all 90 degrees. And you should be able to understand. And that reproducing, many people could not do. Suppose I get a hexagon like this, and if this is to be rotated, it should not change its shape and size. Some people are drawing big, or some people drawing small, or something like that. And completely distorted. Hexagonal pyramid or prism, when you want to reproduce, either you do with auxiliary plane method or do it properly. Nobody is, not nobody, many people are doing it horrible. Okay, another thing is, I think some people are just copying another people's thing. Okay, you can copy, I don't say no, but you have to understand what you are doing. Suppose you get a square pyramid like this, and many people have drawn this as dotted, this as dotted. I don't know how the outer lines can be dotted. Somebody has started it, and all people draw dotted on the boundary lines. Many people. In the same way, if hexagonal prism is there, okay, something like this, if when you draw, if somebody is, instead of joining this, if somebody joins this, other people also doing that only. So on the corresponding corners, I have to join, right? I don't know just how blindly people are doing it. Because at least 10 to 15 people are there like that. But that is a considerable presence out of 70. Okay, reproducing the first figure to second position to second position to third position, that you do properly. Okay, how to do it? You fix one line, okay, some diagonal or edge or whatever it is at some angle. Once you get 2 points, all the other points I have to get from the distances of these 2 points, knowing that I have to put the arcs and get all the other points. Okay, so these are the things I want to just tell. I have written comments. It took me a lot of time, because same comments I have to write again and again for all the people. And another thing also I told, that you have to draw the axis in all the views, in all the problems. Okay. Unfortunately, I have to write that comment to all the people almost. So I repeatedly tell you many times, draw the axis in all the views of all the problems. Okay, so that is another thing I want to tell. Okay, this is the feedback from projections of solids. Okay. Anything else? Okay, if there are no more things, we'll have the story. Shall we have the story? Yeah. And this is about a person. It's a real story. Jeff Bezos. Anybody heard about this name?
Yes, sir.
Who is this?
Founder of Amazon.
Yeah, very good. Nice. At least one person responded. Okay, it is about his story. Jeff Bezos was born in Albuquerque, New Mexico on the 12th of January 1964. Jeff's mother was 17 when she gave birth, and his father was the owner of a bike shop. The pair divorced a few years later, and his mother, Jacqueline, married Miguel Bezos in 1968. and he was a Cuban migrant. And it wasn't long after the wedding that Miguel adopted young Jeff, changing his name to Jeff Bezos. The family moved to Houston, Texas, where he would attend elementary school before moving to Florida, where he would complete high school. He graduated from high school as a valedictorian and mentioned space travel in his graduation speech. It was obvious that Jeff Bezos was interested in science from a young age. His father, Miguel, was an engineer, and his maternal grandfather, with whom he spent many summers with, was the director of the US Atomic Energy Commission. He mentioned colonizing space in his graduation speech, as well as plans to get all the humans off the earth and turn it into a national park. So that is his dream. And he attending college at Princeton University and graduated with a 4.23 GPA and a Bachelor of Science in Engineering with Electrical Engineering and Computer Science. And after graduating in 1986, he was offered many jobs with the top companies, but ended up working for Fittel, which was a startup company. The next 9 years would see Jeff Bezos bounce around between companies, often getting promoted quite quickly, especially for his age. He would work for the Bankers Trust and then for a hedge fund company, which he would become the vice president for before he was even turned 30. He became vice president of that before 30 years. And towards the start of 1994, he decided that he would do something different. He wanted to open an online bookstore. Leaving his job at the hedge fund company, he founded what is known all over the world as Amazon. He chose this name for two reasons: a respect for the Amazon rainforest in South America, and because it starts with A, making it the first letter of the alphabet. Starting with an initial investment from his parents of $300,000, Jeff Bezos told his investors that after doing some careful calculations, that the chance of going bankrupt was 70%. He did have a lot of confidence that because of the growth of the internet, Amazon would eventually take over the bricks and mortar stores, which were his competition. Flash forward 4 years later, and he has expanded Amazon beyond books to include music, video, and other different household consumer items. In 2009, he was named Time Magazine's Persons of the Year. He then went on to create Amazon Web Services. However, by 2002, the company was nearly bankrupt. So in spite of all this work and all, but it was bankrupt in 2002. After the closure of distribution centers and the layoff of 14%, Amazon managed a comeback year in 2003 when they turned out a profit of $400 million. So you can see the ups and downs of even that such big successful people who are considered to be success, right? A successful person doesn't mean that he is always successful in his career, right? Many times there will be ups and downs, and but you have to have confidence to continue like that. So in 2002, the complete company was bankrupt, but in 2003, they turned a profit of $400 million. He and Amazon went from strength to strength after this setback, and in 2007, Amazon Kindle was born. By 2013, he had secured a contract with the CIA, which brought in $600 million, and in the same year, Amazon was named the biggest internet retailer in the world. Despite selling hundreds of millions of stocks in Amazon to fund other projects such as space travel project Blue Origin, he continued to expand Amazon, and in 2007, he hired 130,000 employees for his distribution centers. It would be the next year that Jeff Bezos would overtake Microsoft creator Bill Gates and be officially named by Forbes magazine wealthiest man in the world with a net worth of $112 billion. So that is the position. So you can see how he has gone to that particular state. So what are the lessons that we can learn from him? Okay, one is taking a risk sometimes pays off. Initially, when Jeff Bezos started up Amazon, he informed the investors that there was a 70% chance that the business would be bankrupt. He still decided to take the risk and was rewarded with one of the biggest businesses in history. He took a chance and it paid off big time. And there will always be highs and lows throughout your career. He built his company from the group up, and although he is hugely successful and the richest man in the world, there were definitely times when his career went through a rough spot. He has bounced back from near bankruptcy more than one time, and with hard work and consistency, he has managed to get back on top. Life has ups and downs, but it is important to never give up. And don't take note of the negative opinions of yourself. He is no stranger to criticism, often being labeled by the press as a corporate supervillain. He has even taken fire from politicians in the United States and faced pressure in the Senate. He didn't listen to the opinions of others and kept working hard to build his empire. Okay, that is the inspiring personality. And what is the conclusion? He is unlike anyone in our time. He came from a small town and had a relatively normal life, but he also had a big dream. Working his way to the top of many fields gave him the chance to see how a leader works, but he remained true to his own style and created an online empire unlike anything else on the planet. If you work hard enough and stayed focused on your dreams, the sky really is the limit. Okay, thank you. Thank you very much.